In this video we're looking at combinations, and that refers to how many ways we can select some objects without worrying about the order. So in this particular example here we're looking at letters from the word unit, and all we're worried about is how many ways can we select 3 letters. So if we refer to a previous example with permutations, what we did was try and express as many words as possible using the word unit. Now of course we don't use words like in the dictionary sense, but we do use it to refer to arrangements of the letters where order is important. So in this case the number of possible arrangements can be based on the permutations formula. What we'd do is we'd describe it as 4p3, and that means that we've got 4 letters to choose from, and we're picking out 3 to arrange in a different order. Now here's the actual list of all the possible arrangements, and we can see that in red we've expressed all the ways of writing down the words starting with U, and then in blue all the words starting with N, etc., going through I and T. What we'll then do is we'll take these arrangements and break them down into different groups. We'll actually break them into groups where the letters are the same. So we can see here in green that we've got all the arrangements involving U, N and I. And then in red we've got all the arrangements involving T, U and N, etc. for N, I and T in purple, and then U, T and I in brown. So that means in terms of selections there are only 4 ways that you can select 3 letters from the word unit, and we've got them there at the top of our list. So you can have I, N and U in any particular order, N, T and U in any order, and likewise for I, N, T and I, T, U. So we can see from our table that those 4 ways can be broken further down into groups of 6, and that's all the different arrangements of those letters. So let's have a look at how we could actually work out a formula to work out the different combinations or selections that give us the solution of 4 ways. We know the number of arrangements is 4p3, and if we perform that calculation, that's 4 factorial divided by 1 factorial, which is 24. And here are the 24 arrangements which we saw before. To get the different combinations, we need to be mindful from the list in front of us that there are groups of 6, and those groups of 6 come about because the different arrangements are based on 3 letters, in other words 3 factorial. So to determine the different combinations, we need to know the number of possible arrangements, in this case 24, and divide that number by 3 factorial, because that's the ways of arranging the 3 different letters, and that comes to a total of 4. So there are 4 combinations or 4 ways of selecting 3 letters from the word unit. We can summarize this into a formula for the general case. So if we're selecting R letters or R objects from a total of N objects, the number of combinations is determined by calculating the number of permutations and then dividing it by the different arrangements, which in this case is R factorial. If we put that all together into a formula for combinations and call it NCR, we can see that the final formula is N factorial divided by the product of N minus R factorial and R factorial. Let's have a look at some further examples involving combinations or selection of objects. So in this first example, it's a Scrabble game where we've got a box containing 4 vowels and 5 consonants. And we want to work out how many ways we can select a group of letters if there is to be 1 vowel and 2 consonants. And the key word there is and. They've got to occur together, so we're going to perform a multiplication. This multiplication will involve 2 parts. What we'll do first of all is work out the number of combinations we can get from choosing 1 vowel from 4. And likewise we'll look at how many combinations there are choosing 2 consonants from 5, and we do that by using the combinations formula. So it's 4 choose 1 multiplied by 5 choose 2. Now 4 choose 1 comes to 4 and 5 choose 2 comes to 10, and the product of those 2 numbers is 40. If you're seeing combinations for the first time, it's often wise to see if you can actually list all the possible selections that can occur. And also in this case, if you're using combination formula for the first time, it would be wise to pause here and check to see that you agree with that calculation. In this next example, we are actually working out the number of arrangements because we want to know how many words consist of 2 vowels and 3 consonants from the word computer. But before we actually work out the number of different orders, what we need to do is make sure we make the selection so that we have got 2 vowels and 3 consonants in all the possible arrangements that we've got. So the first thing we need to do is consider how many combinations of these letters are possible. So we can see in the word computer that there are 3 vowels. That's O, U, and E. And there are also 5 consonants, C, M, P, T, R. So what we do is we go through a formula where we select 2 vowels from 3. So using the formula, it would be 3 choose 2, and that's multiplied by 5 choose 3 because we want the consonants and vowels at the same time. 3 choose 2 is 3, 5 choose 3 is 10, and the product of those two numbers is 30. So what that tells us is that there's 30 combinations or 30 selections from the word computer that involve 2 vowels and 3 consonants. They're not in order yet. So to get the number of arrangements or the number of words, we have to multiply that 30 by 5 factorial. That indicates that what we're doing is within each one of those selections, we're working out all the arrangements of the 5 letters, and that's where 5 factorial comes in. So the number of arrangements is equal to 30, that's all the possible selections, multiplied by 120, which is all the arrangements within each selection, and that comes to 3,600. In this next example, we're being asked to work out how many triangles can be formed from the points shown. Now the points are in lines, so in the top line we have 4 dots all in a row, and then we have another line of 3 points in the bottom line. So to form a triangle we need to use 3 vertices. We can use 1 point from the top line and at the same time 2 points from the bottom, or alternatively we can use 2 points from the top line and 1 from the bottom. We're not able to use 3 points from a particular line because to do that would just create a straight line. We wouldn't be forming a triangle. So these two options are mutually exclusive. We can't have 1 point from the top line and at the same time 2 points from the top line. So we'll perform an addition, but we'll need to work out the number of combinations for each part separately. So for the first case where we have 1 point from the top line, we've got 4 points and we're choosing 1. At the same time, so we're using multiplication, we're choosing 2 points from the ones below out of 3. Now we perform an addition, and we're choosing 2 points from the top line of 4, so that's 4 choose 2, and at the same time we're choosing 1 point from the 3 in the bottom line, so that'll be 3 choose 1. Performing this calculation, we can see that 4 choose 1 is 4, 3 choose 2 is 3, 4 choose 2 is 6, and 3 choose 1 is 3. We then apply the operations and we get 12 plus 18, which is equal to 30. So there are 30 triangles that can be formed using the points shown in that diagram.